Okay, so here we're going to be reintroducing friction in the context of statics. Now, there's not really going to be an awful lot, well, actually, there's not going to be any new material in this chapter. It's really just going over an application of what we've already learned. So let's start with something really, really simple. Let's go for a flat horizontal surface. And let's say that we have a force which is supposed to be parallel to the surface, and let's say that that is going to be of magnitude p newtons. Okay, so let's say that the object also has a mass. We keep this nice and easy. We'll go for m kilograms. Okay, well, this is going to allow me to calculate the friction. Okay, so the friction force, because it's horizontal, will just be, well, we take the reaction force, which will be mg, which is equal and opposite to the gravitational component, and so this will be mu mg. Now, if we're told that the object is static, meaning it is not accelerating, then really that means that these forces are balanced. Okay, so that means that we could have P is equal to mu mg. Now, there's one thing which should be noted. That does not necessarily mean that the resistance force or the friction force is always going to be equal to Pn. And by that, what I mean is, imagine that P is actually a variable. So what I mean by that is, imagine that P is, I don't know, let's go for 1 Newton. All right. That doesn't necessarily mean that this will equal 1. So what I mean by that is, if you think about what happens if you have an object on a table and you start pulling, you slowly increase the force. The friction force is actually going to be rising to meet this force trying to pull it. So basically, as this increases, this will actually increase to meet it until, of course, this becomes sufficiently great such that the object will move. So when we use our, excuse me, F is equal to mu r, what we're actually using is a formula to calculate what that breaking point is. So really, we should be adapting this formula to be like so. Okay.